All right, Algebra 2, Lecture 421, 422, OAS A2A21. This is another review. Today we're going to be multiplying binomials using the FOIL method, first, outside, inside, last. And we're going to write the products in simplest form. That means we'll combine like terms, if there are any, and usually there are. The student will factor quadratic trinomials. So we're going to take two binomials, multiply them together, and get a quadratic trinomial. And then we're going to take a quadratic trinomial and break it into two binomials. That's the idea. So here we go. As I said, this is memory lane. I'm going to move that arrow out of my way. We've done this before, but we're going to go ahead and do it again. Multiply. Find the product. Foiling. F-O-I-L. First, outside or outer. Inside or inner. Last. That's what that, I guess that's an acronym, that's what that stands for. FOIL. So here's what we're going to do. We're going to multiply the first term in each binomial. 7x times x is 7. X times x is x squared. That's the first one in each set of parentheses. Then we're going to multiply the outside. This is on the outside far left, outside far right, outside. We're going to multiply those. That'll be 7 times negative 6 is negative 42. X. 7x times negative 6 is negative 42x. Alrighty, now we're on I, inside. That's these two right here. These two are the innermost. So I'm going to multiply those together. 4 times x is positive 4x. And last, the last one in each set of parentheses. Well, here's two. There's the first one. This is the last one. I'm going to multiply this one by this one. The last one in each set of parentheses. 4 times 6 is 24. One of the numbers is negative, so the product is negative. So 7x squared minus 42x plus 4x minus 24, and then we combine like terms if there are any, and there are right here. 7x squared. These are different signs, so I'm going to subtract. That will be 38x, and it will be negative if I do my arithmetic correctly. I hope I did. And 24 won't combine with anything. Remember, to combine like terms, you have to combine terms that have the exact same variable and the exact same exponent. So x squared will not combine with x because they don't have the same the same exponent. They have the same variable, but not the same exponent, so they won't combine. And there's our multiplication, our product. We multiplied these two together and wound up with this quadratic, meaning highest powers of the variables of 2, quadratic trinomial, meaning there are 3 terms. Okay, let's do another one. This is what we're going to be doing every single time. Foiling, taking this one and multiplying it by these two. First, outside. 2m times 5m is 10m squared. 2m times negative 2 is negative 4m. I'm going to take this one, multiply it by both of those. This is the inside and the last. It'll be plus 20m and negative 8. Then I combine any like terms. And these are my like terms right here. I wind up with 10m squared. Negative 4m plus 20m, they're different signs, so I'm going to subtract them and keep the sign of the one with the greater absolute value. And negative 8 won't combine with anything because it doesn't have the same variable as anything else. It's just a constant. There are no other constants. So barring any mistakes, that's the correct response for number 2. And let's see, I got a key around here somewhere. I'll check these. one, 7x squared minus 38x minus 24. Yay! Number two, 10m squared plus 16m minus 8. Yay! Can't believe it. 2 in a row without a mistake. There we go. Factor if possible. Okay, well, this is just a little reminder of how to multiply binomials using the FOIL method. Some people think of the FOIL method as the double distributive method. They say, well, I'm going to distribute this one first, and then I'm going to distribute this one. And you get the exact same thing, FOIL. So we reviewed multiplying binomials using the FOIL method, and we wrote the product in simplest form by combining like terms, and we're going to factor quadratic trinomials. So that's what we're doing right now. We'll have a quadratic trinomial. The way we factor them is we always first see if they have any common factors that I can factor out, which that's a 1, that's a 5, that's a 36. There are no common factors. Then I open up sets of parentheses like this, put the square root of this one, if the coefficient is an invisible or an implied 1, put the square root of this one here and here. Then I look for factors of 36 that will add up to 5. That's numbers that I can multiply together that will give me 36. And the same numbers will add or subtract to give me a 5. So I'm looking at this and I say 9 and 4 will work because 9 times 4 is 36. And 9 minus 4 is 5. So I want to multiply these together to get negative 36. And I want to add them together to get negative 5. And the only way I can add these two numbers together and get a negative 5 is for the 9 to be negative and the 4 to be positive. And then I do a quick check. There's my x squared. These numbers add together to give me negative 5, and they multiply together to give me negative 36, so I'm good to go. This is the factorization of that. Let's take a look at this one. I'm looking for factors of this one, after I open up my parentheses. Factors of negative 90 that will add up to whatever this number is here. It's an invisible or implied 1. So I want factors of 90 that will add up to 1. So I'm going to put the square root of this one here and here. Factors of 90 that add up to 1, that just popped into my head. 10 times 9 is 90. And 10 minus 9 is 1. I got to either add them or subtract them to get 1. So I'm going to go 10 and 9. When I add these together, I want to get positive 1. So it'll be plus 10 minus 9. And then I make sure that my check is, do these multiply together to give me negative 90? Yes, they do. Do they add together to give me positive 1? Yes, they do. So this factorization is correct, providing I haven't made an arithmetic mistake. And I don't think I have, but I'm going to check anyway. If I can find my key. I just had it. There it is. X plus 9 times quantity x minus 4. That's odd. Oh, yeah, this is a different problem. I'm sorry. X minus 9, x plus 10. I had a different problem on there. Weird. That is correct. Okay, I'm going to try to factor this. Factors of 5 that add up to 1. Well, if you stop and think about that, 5 only has 2 factors, 5 and 1. There's no way I can get that. I said add up to 1, maybe. I meant to say add up to 7. I want factors of 5 that add up to 7, and 5 times 1 are 5's only factors. There's no way that the factors of 5 can add up to 7, so we say cannot be factored. That's always a possibility. So there we are. Stumbled through that. Okay. So we reviewed multiplying binomials, combining like terms and getting a quadratic trinomial. Did that a couple of times, and we reviewed factoring quadratic trinomials. And sometimes you can't. So you've done this in the past, you can do it again. As always, I will do any problem on the board. If you need a Zoom meeting, let me know.